Hey guys, welcome to another episode of Coffee Break Hacks, where in the time it takes you to have a cup of coffee, you'll be learning a new hacking tip, trick, or technique. My name is Tariq, and today's episode will be covering Docker files. We'll start by defining what are Docker files and what are the instructions that we see in these Docker files, and then we're going to be creating a Docker file ourselves. From that Docker file, we're going to be creating an image, and then from that image, we'll spin up a container that has vulnerabilities on it. And then, as always, because it is Hackers Academy, we're going to be hacking that image. Please keep in mind that for this video, there are some prerequisites. You need to know the basics of Docker. So if you haven't watched the earlier video, please go ahead and watch it. You'll find it on the Hackers Academy forum. And you need to know a little bit of Linux commands, just the basics, nothing too complicated. I will be walking you through the commands anyway, but if you do have a little bit of knowledge about the basics of Linux commands, you'll be a little bit more comfortable with this video. So let's get to it. What is a Docker file? We mentioned it very briefly in the previous video. In a nutshell, it's a text file, as you're going to be seeing. A very simply structured text file with a set of instructions. When we're talking about instructions, we basically mean commands. Based on these instructions or commands, we are going to be building an image. And the idea or the objective of this is to automate the image creation. So instead of us running a bunch of commands every time we want to create an image and then spin up a container based on that image, what we want to do is to automate the image creation. So we're going to put all of these commands in one file and then issue one command that will go and read this file sequentially and create an image based on that file. So let's have a look at what these instructions might look like. Obviously, there's a syntax to these instructions, pretty much like with any scripting language or any programming language, there is a syntax that we need to follow. Lucky for us, it's pretty straightforward when it comes to Docker files. The syntax is this: anything that is preceded with the hash sign signifies that this is a comment. So this is just to keep comments or notes to remind yourself or other people looking at the file what's going on. So the Docker daemon or the Docker program will ignore the line that follows the hash sign. The first instruction, with very few exceptions, that we need to use to start our Docker file is the from instruction. Now you'll notice that these instructions are all in caps. This is just a convention. It is not case sensitive, so you can use lowercase, you can use uppercase, it doesn't matter. The convention though, however, to make it easier for you and for others to read what you've written, is to use the instructions in caps. So from is the first instruction that we usually start with writing our Docker file. And I'll tell you what from means in a moment. And then we start building up our instructions. And usually they are an instruction, again written in caps, followed by some arguments. Don't worry, we'll be seeing an example very shortly. So once you finish writing the Docker file, what happens is that the Docker daemon or Docker program is going to validate your instructions and make sure that you don't have any syntax errors. You haven't messed up any commands, you haven't left, for example, some commas or semicolons in places that you shouldn't have left them, and so on. So it will just verify and validate that the syntax is correct. If there is any errors with the syntax, you will get alerted. An error will be thrown back telling you that there is an incorrect syntax. So you need to go back and double check what you've written. If there is no syntax errors, then the program will proceed and you can build the image. So let's have a look at some actual instructions. Like I said, we will be starting with the from instruction. And the from command basically sets a base image to initialize the build. We talked about what a base image is in the previous video. So let's say, for example, I'm basing my image on Ubuntu or on Debian or on Windows Core. This is the first thing that I need to specify. So you'll see in our example here, I'm starting with from Debian. So my base image is Debian. This is where I'm starting. Notice, however, that my instruction is not all in caps. This is not going to affect the Docker file. It is still going to run absolutely fine. I did that on purpose just so you would see that the capitalization doesn't really matter. It's just a convention. The second instruction we'll be looking at is the run command. And what run does simply is that it executes command in a new layer and it commits results. In other words, in this example, we're creating an image from Debian. The first command we're running is to change the root password. So we change the root password, and then we will commit these changes to our image, and then we'll carry on with the next command. We'll run the apt-get update. Once that's done, we'll commit the changes to the image. As a side note, in the next video, we'll see how to commit an image after we do a whole bunch of changes and save that as the new image. For now, what we need to focus on is that the run simply executes commands one by one and commits or saves these commands on our image. And the last instruction we'll be looking at in our Docker file today is the entry point. The explanation of entry point can get a little bit complicated. The easy way to look at it for the sake of our example today is that we need to specify a command to run when the container starts. So whenever we run the container, we want a command to run by default. In our case, it's going to be starting a service, as we're going to be seeing in the video. Now, obviously, there's a whole bunch of other instructions that we are not going to get into for the sake of keeping this video short. But if you want to explore this a little bit more, feel free to go to the Docker documentation and you can read all about all of these commands. For example, the copy command, the cmd command, and so on. For now, we're just going to keep it simple. So from will select the base image and initialize the build. Run will simply execute commands, layer them one on top of each other and commit each command when it's done. And the entry point will specify a command to run or execute when the container starts. Alright, let's have a look at what we're trying to do here. In a nutshell, I'm trying to install a software called Webmin on a Debian base. So let's say I was installing it on a Debian virtual machine. All I need to do is follow these instructions in this documentation and I'll end up with having Webmin installed. So the process would be to actually try these commands in your container, make sure that everything works absolutely fine, and then if they do, translate these to a Dockerfile so you can automate the process. So this is what I've done in the background. Now obviously I'm not going to be showing you how I did that because that process took me a couple hours. There has been some errors, for example, with dependencies and so on. And this is, like we said in the last video, what makes containers and Dockers absolutely fantastic. Once you resolve all these issues with dependencies and with installation errors and so on, then you can automate the process so you don't have to do it every single time you want to build an image or a container. So I'm going to be taking these commands, changing them a little bit, and I'm going to be explaining what I'm changing and why. And then once I'm done, I'm going to have a Docker file finished that based on which I can create my image. And the finished product of the Docker file is going to look like this. Let's walk through this instruction by instruction. From Debian, you know by now that this is my base image. I'm asking Docker to create my image based on Debian. So this is simple enough. Second instruction, I'm running a command to change the root password. So I'm echoing the username and the password into the change password command. And we're going to be needing that later on when we try to hack our vulnerable container. Then I'm running the apt-get update. And this is when I start writing some comments. Exit 0, which you're going to be seeing at the end of one of these commands, will return success even if there's an error. Why am I writing this? If you look at the apt-get install command, you'll see that I'm trying to install something called apt show versions. When I'm trying to install this on Debian, it doesn't install successfully. It fails the installation. And what happens if an installation fails when you're trying to build an image? Docker will exit completely. It will not continue. And I don't want that to happen. I want the Docker to continue to build the image because following that, I'm running a few commands to fix the issue. So you'll notice, for example, in the following command, the rm, I'm removing the files from the apt show version. I'm deleting all of it, and then I am installing it again separately on its own. And that will fix the issue. But for me to get to these steps, I need to make sure that Docker, when it's building the image, it's not going to trip over this error and exit. So exit 0 tells the Docker program that even if you see an error, ignore it and assume there's a success message and just keep going on. The second command says also install wget. So looking back at the apt-get install command, you'll notice that the first thing I'm trying to install is the wget program. Reason being is that when we're using the Debian base image, it doesn't come with wget pre-installed. And we will be needing wget later on to grab the deb package from SourceForge. If you look at this command here, we're using wget to download the package that we want to install. So I need to install wget as well. So in summary, the apt-get install is going to install some packages. All of these are dependencies for Webmin to run correctly. However, the apt show versions is not going to install properly. It's going to fail. So at the end of the line, I'm using the exit 0 instruction to tell Docker to ignore the failed error and just carry on with the next command. So Docker will carry on with the next command, will remove the files from the apt show failed installation, and then I will install the apt show versions again. Following that, I'm going to execute the wget command to grab the Webmin version 1.9. I don't want the latest version, I want the vulnerable version. And then after that, I'm using the D package to install the Webmin package. And last but not least comes the entry point instruction. And this is the command that I want to execute when the container starts. When I start the container, if I don't have this entry point assigned, I'm going to have to start Webmin manually. However, because I want to automate this as much as possible, I'm specifying an entry point that says service Webmin restart. So when I start the container, Webmin will restart automatically and bash meaning when I start the container, take me straight away to the bash shell. So instead of me typing the usual docker run -it, the name of the image, and /bin/bash, all I do is docker run, and that will automatically take me into the bash shell. So now that we have the Docker file ready, all we need to do is build an image based on that file. And the command to do this is pretty straightforward: docker build and dot. Dot annotates the current directory that I'm in, and this is where the Docker file is. And the build starts. So here I'm speeding up the video quite a bit, but I'm going to be stopping at some important time intervals to explain to you what's going on. So look at this. We're getting an error here while trying to install the apt show versions. Normally, if I didn't use the exit 0, the Docker build is going to exit here, and it's going to throw back an error at me saying I cannot proceed. So what I did is that I used the exit 0 to tell the Docker build to ignore that error, assume it is a success, and keep going. And this is where we continue to step 5 out of 9. We remove the residual files from the failed apt show installation, and then we try to install it again, and this time it succeeds. This is in step 6, where we see it installing successfully. And then the build carry on to the end of the instructions. Brilliant. So now we have a successfully built image. Let's try to run it. We know by now to spin a container out of an image, we use the docker run command. I'm going to add the -it options and the image ID. Notice here that I'm not doing /bin/bash as I used to do before. And this is because I specified in the entry point 2 things. 1, that I want to restart the webmin server, and 2, that I want to land in the bash shell. So when I run this, you're going to see an output saying the webmin service is starting, and then I'm going to land in the bash shell. Let me double check. I'll run service webmin status, and webmin is starting. Perfect. Let me grab the IP address of my container. There it is. And let's verify together that webmin is installed successfully. I'm just going to open a browser, and webmin runs on HTTPS port 10,000. And here we go. It looks like it's working. I'll add an exception and I'll land on the login page. This is where we need the username and the password, by the way, that I specified at the beginning of the Docker file. So I know this is a vulnerable version of webmin, and because it's Hackers Academy, we have to play around a little bit with vulnerabilities and exploits. So let's fire up Metasploit from another container that I've built. We've seen how to do that in the previous video, and I'm going to search for webmin. I'm going to use the webmin upload exploit, and I'm going to set the options of the exploit. Again, this is pretty standard Metasploit procedure. We've seen this in many previous videos, so I'm not going to dwell too much on this. I'll just go ahead and start setting the options one by one. And once I'm done, I'm going to run the exploit. And here we go. I have shell access. I'll type who am I? I'm root. I type ls, and I can list the content on the vulnerable webmin server. Perfect. So we created the Docker file from scratch. We used that Docker file to create an image, and from that image we managed to spin a vulnerable container that we could play around with and test our Metasploit skills against. In the next video, I'm going to be teaching you something pretty cool. How you can do 2 things. 1, how you can commit changes to a container and save it as a new image. So let's say, for example, here, after we spun up the webmin container, we did some changes. Maybe you changed the password, maybe you changed the homepage, maybe you wanted to change the port from 10,000 to port 80, or whatever it is. We're going to be seeing how you can commit and save all of these changes, and then after you save these changes, you can create an image based on the newly saved changes. And once you save that new image, we're going to be seeing how to save this image on a public repository called Docker Hub, so that you can later on pull that image from the cloud and spin up a new container whenever you want. So if I do, for example, here Docker search Hackers Academy, you'll see that in our repository, you have the vulnerable webmin version 1.9 waiting for you to be pulled down and for you to spin up a container from it straight away. So we're going to be seeing how to do that in the next video. And with that, we reached the end of this video. I hope you enjoyed it and you found it useful. And until next time, happy ethical hacking.